Hi, you guys. Today I have with me problem 5.9 from Young and Freedman's University Physics textbook. I've been having an awesome Sunday doing absolutely nothing all morning except bed rotting and watching this new scary show my friend suggested, reading, knitting, and just doing things that I really like. Including making videos this morning. Yeah. That's what's up with me. All right, let's get started on this problem. But before we do that, please don't forget to like and subscribe if you haven't already. Okay, so a man pushes on a piano with mass 180 kilograms. It slides at constant velocity down a ramp that is inclined at 19 degrees above. I'm just gonna go ahead and write down, I think I forgot to include that when I was typing up this problem or formatting this problem. So 19 degrees above the horizontal floor. Neglect any friction acting on the piano. Calculate the magnitude of the force applied by the man if he pushes A parallel to the incline and B parallel to the floor. Okay, so interesting question. Um, it's a little bit different than a lot of like other, well, it's not like so much different. It's just it's interesting practice, I guess. Okay. It's good practice. All right, so let's go ahead and start with a diagram as we typically do. So we have a piano with mass 180 kilograms, and it slides at a constant velocity down a ramp that is inclined at 19 degrees above the horizontal floor. So let me just go ahead and draw this ramp first, right? So 19 degrees, and there is a box with a mass of 180. So like, well, no, it's not a box. Let's pretend the piano is a box. Let's pretend the piano's inside of a box that's massless. Yeah, because I don't want to draw a piano. I'm not very musically inclined, by the way, but okay. Besides the point. So mass 180 kilograms, and then constant velocity down a ramp. Okay. So that's the constant velocity and 19 degrees above the horizontal floor. Cool. That's the incline of the ramp. Neglect any friction acting on the piano. Calculate the magnitude of the force applied by the man if he pushes A parallel to the incline and B parallel to the floor. So there's some man and he is pushing either in A parallel to the incline, right? Or B parallel to the floor, right? So those are our two possible directions. And as we do in every single problem, we want to go ahead and create a little coordinate system. Oh, actually, I'm going to do it the opposite way. I'm going to make this positive, well, like we did before. So that's going to be our positive y direction. And I'm going to make this like parallel to the inclined ramp, the positive x. Okay, cool. All right. So one thing I want to point out in this question, actually, no, we'll point that out after. Now let's go ahead and write down all of our knowns. Okay. So knowns. Mass is equal to 180 kilograms, right? And then the ramp, so theta ramp is equal to 19.0 degrees. And that is all the information that's really given as like a known, right? All right, what are we trying to figure out? The magnitude of the force applied by the man if he pushes parallel to the incline and be parallel to the floor. So what we want to do is we actually want to go ahead and draw for A. for each situation, we want to draw a force body diagram. So let's do that. So for scenario A, let's have a force body diagram, and let's do it in pink, right? So again, like let's pretend this is our ramp. This is going to be our piano. And then there's obviously going to be force of gravity acting on it, on this piano, right? And there is no friction, right? It says neglect any friction acting on the piano. Because this piano is in contact with the surface of a ramp, there's going to be a normal force which is perpendicular to the surface of the ramp, and that's going to be Fn. And then there is going to be a force applied by the man that is parallel to the incline. So that's going to be in this direction, right? Because if the man is right over here, then he's pushing like in this direction, right? So I'm just gonna draw it right over here. And that is going to be our F, right? Or we can call it FA because that's the force applied in situation A. Okay. So what are we looking for? We're looking for what force A is. Okay. So as we do whenever we want to find out we want to isolate for the magnitude of one force, we're going to go ahead and we are going to write down a statement, or we're going to write down the summation of forces in the X and Y direction, right? Yeah, we're going to go ahead and write down the forces in the X and Y direction. All right. Let me do it in pink. Okay. So Fx and Fy, right? So the first thing we want to recognize is that the summation of forces in the Y direction, right, for this piano is obviously going to be 0, right? This one's easy because like there's no indication that the piano is moving up or down in this Y direction that we set up for ourselves, right? In the Y axis, there's no motion, right? That's easy. Okay. However, it says that it slides at a constant velocity down a ramp, right? So the constant velocity, that is in the positive X direction, right? The constant velocity is in the positive X direction. And 1 second, I just want to make this really easy. So okay, I actually can't find the thing that I was looking for to make this like super easy. I was actually going to quote something, but I can't remember what it is that I wanted to quote. But what I was going to say is that the constant velocity that is down the ramp, that is also 0. Okay, sorry, the force, the summation of forces in the X direction that we set up for ourselves, because we're given the indication that there is a constant velocity, that is also like there's no acceleration. So that means that it's 0 as well. Okay, and this is just one of the keywords that you're gonna have to pick up in the question. I remember there was more context for this, but I forget exactly like what it was that I used to use when I like first learned this concept, but it's fine. Maybe it'll come back to me in the video. But the important thing is that we're given this key information that it slides at constant velocity down a ramp. And because it slides at a constant velocity, that means that acceleration is 0, right? Because force is equal to mass times acceleration. And we're told that because there is no acceleration, that means that the net force, it has to be 0. Because if this is 0, then this has to be 0. So the summation of forces in the X direction, right? The X direction that we set up for ourselves, this is 0. Okay, so now let's go ahead and write down all of the forces. So one thing we want to recognize is that yes, FA is in is aligned with our coordinate system, right? So let me just rewrite that over here. So that's going to be our positive y, and that's going to be our positive x. So it's easy for like FN and FA, but we want to recognize that FG is not completely aligned with this coordinate system. And so we have to break it down into components. We have to break it down into the X and Y component. And we know that this is 19 degrees. So this angle over here, that is also 19 degrees. And we want to break this down into the X and Y component of our coordinate system. So let's go ahead and do that. Well, this is going to be FG cos 19. And this component over here is going to be FG sine 19. All right, so now let's write down the summation of forces in the X direction. And that is minus FA, right? Minus FA because it's in the minus X direction. Minus FA plus this positive FG sine 19 is equal to 0, right? And then for the summation of forces in Fy, well, this one's easy, right? We said it was equal to 0, which means that this component is equal to this component. So Fn, because this is in the positive y direction, so positive Fn minus Fg cos 19. And I realize this is redundant, so I'm just going to erase this. All right, so there we go. And now we want to solve for this. We want to solve for what FA is, okay? And because we want to solve for FA, we can just use this equation right over here because there's one unknown and we just have to isolate for that, right? So FA is equal to FG sine 19, right? And we're just gonna break this down to, well, FG is equal to mg sine 19. And we're gonna plug this into our calculator because we know that M is 180 kilograms and then G is 9.8. So 180 times 9.8 times sine 19 is equal to 574.3 newtons, right? So that is the force that would be applied by the man if he pushes in the parallel direction, if he pushes parallel to the incline. Okay, so now B. Okay. So we solved for A, right, which is just right over here. And actually, I should probably go ahead and do the significant figures as well. So in this problem, there's two significant figures because there's two significant figures here and there's three here, and we always go with the lower amount. So this is going to be 570 newtons. FA is equal to 570 newtons. Okay, now for B. B, what happens if the man is pushing parallel to the floor? So what is going to be the force then? And we're just going to call this force FB, right? Let's do it in orange. Let's just call that FB. And again, we're going to go ahead and draw we're going to go ahead and draw a diagram, a force body diagram. Okay, so downwards, right? We're gonna have, again, the same basic setup. FG is downwards, FN is going to be perpendicular to the surface, and then FA is no, or it's FB now. FB is not going to be parallel to the incline. It's actually going to be perpendicular. It's going to be parallel to the floor. So this man over here is going to be pushing like this, right? That makes sense. Okay. So that's going to be FB. Cool. So again, we're going to use this exact coordinate system that we already set up for ourselves. Yeah, okay. And we want to solve for FB. So again, we're going to have this component over here be FG cos 19, and this is going to be FG sine 19. And then we actually also have to go ahead and do that with this component, with this FB, right? And how do we know what this is? Well, let's figure it out. So if this is parallel to the surface of the ramp and this line is parallel to the floor, well, similar triangle, we said this is 19, so that means this has to be 19 as well. And so there is going to be a component this way. Actually, I should use a different color so that it's a little bit more clear. Let's do pink, actually. Let's do purple, actually. That'll be easier. Okay, so over here, we're going to have one component, right? And this is going to be FB cos 19, right? And then we're going to have this FB sine 19, right? Awesome. So now we just have to go ahead and write down the summation of forces in the X and Y direction and then just isolate for FB. So let's do that. So again, it doesn't matter which direction the man is pushing. The basic, like the skeleton of the question remains the same. It's still sliding at constant velocity and it's still not moving up and down in the y-axis. So we still have 0, 0. And for x, let's start with that. In the x direction, now we have same FG sine 19 in the positive direction. Right, so FG sine 19, right? And then we have, then we have FB cos 19 in the opposite direction. So minus FB cos 19. Cool. Okay. And then in the y direction, let's do that. So let's do the summation of forces in the y direction. We have Fn, right? And that's positive Fn. Positive Fn minus FB sine 19, and that's downwards. And then again, minus FG cos 19. Okay. And what we want to do is isolate for FB. So again, we have Fn is unknown, and then we have FB here and we have FG. So we don't want to deal with two unknowns. We just want to deal with one unknown. So this statement over here, we can just one statement, one unknown, so we can just isolate and solve for FB. And that is going to be FB cos 19 is equal to FG sine 19. FB is equal to FG sine 19 over cos 19. And then we get sine 19 over cos 19, that's tan 19. And FG is MG, so MG tan 19. And from here, I'm getting FB is equal to, and I'm going to plug these values into my calculator. So we know that M is 180, like we said over here. And then G is 9.8. So 180 times 9.8 times tan 19. And I'm getting 607.4 newtons. And with significant figures, that is FB is equal to 610 newtons, right? So that's our solution for A and for B. I hope that was helpful. And if it was, please don't forget to like and subscribe. Thank you so much for watching.